Hello everyone and welcome to Network Playroom. Today we're having fun with Python. We're going to solve an interesting mathematical problem. How is this related to networking, you may ask? Well, to solve this mathematical problem, we have to use basic Python constructs which also apply to network automation. So the programming logic and tools you learn from this video will also transfer to network DevOps. Now, before we solve the actual problem, I'll provide some background on the subject and introduce the resources we'll be using in this video. Also, a quick disclaimer here, I'm not a programming expert. I have done coding in Java and Python in the past, but not really beyond intermediate level, and it was a long time ago. Therefore, my solutions are probably not the most elegant and beautiful, but they will produce the correct answer. So while there are perhaps more efficient ways of solving the problem, my code will also get the job done. That's all I care about at this point. I can come back to these later as I learn more and my coding skills improve. You can also let me know in the comments how you would have solved the problem, because there are multiple ways of solving the problem. We can share some ideas. I'll focus on my main solution throughout this video, but I'll cover an alternative solution briefly at the end of this video. If you don't want to watch the entire video and you want to skip to a certain section, there will be timestamps in the description, so look for those. With that said, let's get started. So first, let's go over the resources I'll be using in this video. Number one, I'll run the code on my Windows Subsystem for Linux, or WSL, right here. I have Ubuntu installed, which is basically running as an app on my Windows. How cool is that? I took a screenshot so you can see that it is actually Ubuntu, although it's not clear from this black screen here. My machine is called Jarvis, by the way. Now, number two, I have the Python interpreter open here as well, right here. Another black screen. So I can show you a couple of things as we work through the problem. The Python interpreter operates in interactive mode, which basically means that it executes the code immediately. In other words, you don't have to compile the code in a file first and then run it. It's a great tool for quickly running code and testing things. Now, number three, the problem we are solving is from a website called Project Euler. I had it open here previously. Let's go back. This page right here. Now, Euler is a reference to the Swiss mathematician Leonhard Euler, who made important and influential discoveries in many branches of mathematics, including graph theory, actually, and contributions to mathematical notation. By the way, I'm hoping that I'm pronouncing that name correctly. I believe it is Euler, but let me know in the comments if I said it wrong. Now, a quick knob here. One of the famous problems that Euler solved, or actually proved unsolvable, is the 7 bridges of Königsberg problem. Look it up if you're interested. Okay, now back to the web page and Project Euler. If you haven't heard of Project Euler before, it is, quote, a series of challenging mathematical/computer programming problems that will require more than just mathematical insights to solve. Although mathematics will help you arrive at elegant and efficient methods, the use of a computer and programming skills will be required to solve most problems. So basically, these problems combine maths and programming in a creative and challenging way. And let me tell you, these problems get very difficult very quickly. Even as you begin with the first problem, you can't cheat your way through it by finding the correct answer by hand. You also need to pay attention to the algorithm you write, especially with the more difficult problems. If it's not efficient, your program will run for longer than you probably live, from what I remember. So I was first introduced to this site when I was studying programming at the university like 10 to 12 years ago. I can't believe it's been that long. saying that out loud is kind of giving me an age and identity crisis. So anyway, before I lose my track of thought, back in 2008 to 2010, I was really into Java before I got into Python. I solved maybe a handful or a dozen of these problems back then. So let's see if I can do any better this time. The problems are very challenging, but also extremely rewarding once you get your code to work. So let's actually take a quick look at them. You can find all the problems under archives right here on this link. So you can see there's a lot of them, 15 pages, and they get increasingly difficult. So we'll just stick to the first page and we'll start with the first problem. So let's go to problem number 1, right here. So let's read through the problem first. The title is Multiples of 3 and 5. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1000. So our problem is right here on this line. Find the sum of all the multiples of 3 or 5 below 1000. Now first, before we write any code, let's think about the logical process to find the answer. So number 1, let's make sure we understand what we are doing. So we need to find all the numbers which are multiples of 3 or 5 up to 1000. So we need a test or a condition to check if a number in range from 1 to 1000 is a multiple of 3 or 5. And number 2, if the number in question is a multiple of 3 or 5, then we need to add that number to the sum. And then the answer is the total sum of the numbers which meet that condition. So these are essentially the two problems we need to solve by writing code in Python. So let's think about the first part, about how we can test if a number is a multiple of 3 or 5. Now for that, we can use the Python modulo operator, which is the percentage sign. So the result of that is the remainder of the arithmetic operation. So to check if a number is a multiple of 3, the remainder should be 0. Let me pull up the Python interpreter so I can show you the line of code that we're going to write. I'll do it in multiple parts and then we'll put the code together at the end, so bear with me here. So now, to test if a number is a multiple of 3, we can write the following. We can do number, then modulo 3, typing the wrong keys here, 0. So this test, or this line of code tests if a number is a multiple of 3. That's going to produce an error because that's not proper Python code yet. But I wanted to do that so we'll still see the code there and it'll make more sense once we put everything together. Now the problem stated that we need to find multiples of 5 as well. So we'll write a similar condition with number 5. So number modulo 5 equals 0, like so. So now we can combine these conditions in one line by using the OR operator and putting them in an if statement, like this. So if number 3 equals 0 or number modulo 5 equals 0, like so. Again, I'm gonna hit enter and it's gonna give us an error. This is not doing anything yet. Okay. So now we have the condition ready. This will check if the number is a multiple of 3 or 5. In other words, this is checking if the number is evenly divisible by 3 or 5, and that is the case when the remainder is 0. So that's why we wrote equals 0. Next, we need a way to test the numbers from 1 to 1000 against this condition. And we'll do this by using a for loop. Now, for loops are traditionally used when you have a block of code which you want to repeat a fixed number of times. The Python for statement iterates over the members of a sequence in order, executing the block each time. So we can write for number in range 1000. This is our for loop. Now again, hitting enter just so we can see it there, but it produces another error. So this line of code essentially means that the program will run the block of code that comes after it 1000 times. It'll be more clear once we put everything together. So the block of code is the if statement that we wrote earlier. Now we need to write the final part, which is to define what action to take when the condition is true. So what we want to do is to add the number to the sum if it passes the check. In other words, if the number is a multiple of 3 or 5, add it to the sum. Now for that, let's first create a variable and call it sum, and we'll initialize it to 0. So this will be an actual line of code. We'll do sum equals 0. Now what we want to happen is to add the number to the sum if the condition is true. In other words, we want the sum plus the number. Now kind of like in an Excel sheet, you have the running total or cumulative sum. We want to do the same here. Now the way to do it in Python is like this. We would do sum plus equal number. Now I can hit enter here again and it should produce an error because we have not defined number yet. There we go. Now writing the code this way is effectively a shortcut of writing sum equals sum plus number. So we could have done it this way. Sum equals sum plus number. So the plus equal is an assignment operator, and here it is used to add a value to the variable and then assign the result to the variable. I can actually demonstrate this by just using 2 random variables and show you how it works. So we can define something like x equals 3 and then y equals 5, for example. So now we can write either like x equals x plus y. So what this line of code will do is add together the original value of x, which is 3, and the value of y, which is 5, and then assign the result of that to x. I hope that made sense. So the result is going to be 8. The new value of x will be 8. Let's try that. So now if we pull x, it's going to show us 8. And the value of y is still 5. Okay? So now we can do the same thing with the shortcut. We can do x plus equal y. So it's going to do the exact same thing as the line before, but now we've used the shortcut. So essentially it'll add 5 to the current value of x, which is 8. So the result will be 13 now. Let's try it. Let's pull x again. You see it's 13. Okay, back to our problem. So we have all the pieces ready to solve the problem. We just have to put them together. So we already defined sum. We don't have to do that again. So sum equals 0. Now let's write the entire code for this problem. So remember, first we have to do the for loop to iterate through the numbers from 1 to 1000. So we'll write for number in range 1000. Then we write the condition if number modulo 3 equals 0 or number modulo 5 equals 0, then we want to add the number to the sum. Plus equals number. And that's it. Now we should have the answer stored in the variable sum. So let's print that. Print sum. And that's it. That's the answer. So let me actually show you what happens with the if statement in the block of code here. So for that test, we can actually use the x and y to demonstrate when the condition is true and when it is false. So if I do effectively the same thing with y, so we'll write y modulo 5 equals 0. So this is going to produce true. You'll see that the Boolean test here is true. On the contrary, if we do the same thing with x, it's going to produce false, like this. So this is what is happening with the programming logic. When that condition is true, when the if statement is true, it's going to the next step, which is adding the number to the sum. And then it'll repeat again with the for loop. If the condition is false, that step will not be performed, so that number will not be added to the sum. Now, I've already written the code on my Linux system, so let's look at that quickly as well. Right here. Let's do ls to see what I have here. You can see that I've already solved a couple of the problems. So let me actually just run the code right here, and then I'll open the file and we can go through it quickly. So to run this from the command line, we'll do Python 3 problem1, and you'll see we get the same number. So now if I open that file, edit it in Nano, so here's what I have. I have some comments here. Exactly the same thing. So we create the variable to hold the sum, and we start it at 0. And then we create the for loop to iterate through the numbers. And then there's the condition or the if statement to test if the number is a multiple of 3 or 5. And then we add that number to the sum if the condition is true. Now here I've just used n instead of number, so this is why this looks slightly different. And then the final line, we just print the sum, which is the final answer. So there you have it. That is my solution to this problem. For those of you who do not wish to see an alternative solution, you can end the video right here. So thank you for watching, and I'll see you next time. For those of you who are still here, thank you for staying. So let's look at the code for the alternative solution. I won't explain the logical process and break down every line of code again, because much of it is the same as with the main solution. So for the main solution, we used a for loop, and for the alternative solution, we'll use a while loop. So let me just open up my Python file right here. So nano problem 1. There we go. This is the alternative solution using a while loop. Now, in contrast to the for loop, which repeats a fixed number of times, the while loop runs until the condition changes. So it could theoretically repeat a block of code forever. Okay, so let's go over the code. Let me start down here so we can look at the parts that are similar to the for loop solution that we looked at before. So here you can recognize the if statement. It is exactly the same as in the other solution. And also the sum plus equals x is effectively the same as what I used in the other solution. So those lines should be familiar to you. So x here is referring to the number to be tested, whether it is a multiple of 3 or 5. So while x is below 1000, this loop will iterate, this loop will continue. So you can see here we have initialized x to 1. It was not necessary to start at 1 because if you're looking for multiples of 3 or 5, clearly 1 is not either. But I just wanted to do that so it would be kind of similar to the for loop. So that's the only reason. Logically, it doesn't make sense. And then we had the same statement here, sum equals 0, as in the other solution. So let me go down the code a little bit because I've commented a line of code here. And this part is very important. And here is the difference. So before we move on to the next iteration of the while loop, we have to take action on the number. So we have to increase the number, or we create a logical problem where the program will run forever. And this part is crucial. So that's why you need this line of code that I've currently commented out, this x plus equals 1. Now also note that it is very important how you indent the code. Indentation is a core concept in Python, and it is used to determine the grouping of statements. Indentation can break or make a program. So let's actually think about what will happen if the indentation is wrong. Now pause the video for a moment and think about where you would write the statement and why. What would happen if you placed it differently? So let's think about where we can put that line of code. So let me get rid of the comment. So we can put it either here or here. What do you think will happen if you put it here versus if you align it with the if statement right here? Well, let's not just think about it, let's actually run it. So let's first do it this way. So we're gonna write this to the file. Let's exit out and then run this. Nothing's happening. So now we have created that logical problem and the while loop will run forever. So we have to break out of it with Ctrl+C. Okay, let's go back to the file and think about what happened. So now let us become the Python snake and slither our way through the code logically. So let's go to this while loop right here and think about what happens. So while x is below 1000, if x is a multiple of 3 or 5, then add x to the sum and then increase x by 1. So perhaps you caught the logic problem already as I read through that. So the problem is that x is only increased when the condition is true, because that line of code is written under the if statement. So right here, this part only executes if this if statement is true. And we start with x equals 1. So the process for this program is while 1 is less than 1000, which is true, then it goes to this block, the if statement. If 1 is a multiple of 3 or 5, which it isn't, so the program never goes to this part. It doesn't add x to the sum and it doesn't increase x by 1. And that's why our code is broken. So let's fix that. So what we have to make sure with the indentation is that the x plus equals 1 is not under the if statement. So let's align it properly. So we'll do it like this. And then let's write that to the file. And then let's try to run the program again. See, now it works. So if we look at the file again, so now what we've done is, since we removed that x plus equals 1 from under the if statement, it's gonna increase the value of x whether the if statement is true or not. So we don't have that logical problem of an infinite loop anymore. Okay, let's exit out of this. So that's it. We've solved this problem using both a for loop and a while loop. Thank you for sticking around until the very end. I'll see you again in the next video.